Hello everyone. We're going to work on now surface area and volume. So you've had all the equations for perimeter and circumference and area, and now we're going to translate that into surface area. Surface area of a shape is the area of each face, so the area all the way around. So remember, one face is just this side. So the top, the bottom, then the left, the right, and the back, all of those would make up your surface area if you added them all together. So we're not talking volume, we're not talking the amount inside, we're talking the space all the way around. Okay. So for example, if you were trying to paint a house, you might need to know your surface area, or the amount of space you had to cover with paint, before you bought the paint. Volume would be how much you could fit inside of your house if you packed it to the brim. So when we talk about a prism is something that has two bases, okay? So a top and a bottom. And before we get into the formula, let's check out a few more. So we can have a triangular prism. Sorry, I know this is hard to read, but triangular prism has a base that is a triangle. So when you're searching for the formula for area of the base, we would here use 1/2 base times height. And base, remember, just means the length of the bottom. And your height is your altitude. Then we could have a rectangular prism. So here you can pick whichever side you want to be your base. If you decide that you want the left and right to be the base, you can do that. You could also use top and bottom or back and front, but whatever sides you start with as your base, once you name a base, everything else follows from that. So remember, for area of a base, if it's a rectangle, your area is just the base times the height. So here would be my height, here would be my base length. Okay? And that's the area of the base of your prism. So don't get confused when I say base, because base of a prism means the flat surface, whereas base in an area formula just means a bottom side. For a cube, again, you have two bases, or you could go top and bottom, but they're all the same. So cubes are made up of squares, so your area is your side length squared for one of your bases. We get down to a pentagonal prism, or you can have a hexagonal prism, an octagonal prism. Depending on how many side lengths you have, that name will change. And we know it's hexagon because it has a pentagon because it has 5 sides. And so since you have 2 of those can be considered your bases. And next you have next to it a hexagonal prism. So 1, 2, 3, 4, 5, 6. And again, we have 2 of those, so those become your bases, and then your height comes from the side. And area for polygons is, area is 1/2 your perimeter times your apothem. And you'll have to calculate that depending on what kind of shape you're given. Okay, so for surface area, we want to find the area of all the spaces all the way around. So what you can do is find the area of each face and add it up, but some of them are repeats. So if we think about the bases here, it's your surface area, and for that we use the abbreviation SA. Well, we have 2 of the same bases, so it's 2 times the area of your base. And you're going to add to that the area of the lateral faces. And so you might have all the same areas, or they might be different depending on the side lengths of your base shape, that triangle. So if it's an equilateral triangle, then your lateral face will all be the same size. However, if it's not, then you're going to have to find the actual area of each piece. So the last piece is adding area of each lateral face. Okay, for volume, we are finding the area of the base. Oops, I keep doing that. So volume this time is with a V, so area of the base. And you're going to multiply that by the height, okay? And so height here could be this altitude on the right-hand side. All three of these pieces should be the same height if it's truly a prism, okay? So let's make up an example here. Let's say my altitude is 12, and I have one side that's 10, another that's 10, and I know that coming straight down here, that altitude, that piece is going to be 5. If I say this is an equilateral triangle, that can be 5. And then we have created, if we take an equilateral triangle and split it in half, you can either use Pythagorean theorem, or, if you remember, this would be now a 30, 60, 90. So that angle up top would be 30, since we split a 60 in half, which makes this side length, or my height, 5 radical 3. So to find the area of my base for my surface area, it's 1/2, so, 2, and then area of a triangle is 1/2. The base length here is going to be 10, because it's equilateral, so times 10, times the height, which is 5 square roots of 3, okay? And then we want to add to that the lateral area. So each lateral face is actually a rectangle. And since this was an equilateral triangle, all three faces are the same size. Now please be aware that will not always happen. But if I want to find the area of a rectangle, it's the length, so 12, times the width, which is 10, so 120. And we have 3 of those sides, so 3 times 120 will give me my value. Well, if I combine all of these values, 2 times 1/2 is just 1, and then 10 times 5 radical 3 is 50 radical 3, which is about 87 if we want to do it out, and then we're adding to that 360. So we get 87 plus 360, and that should be equal to 447 units squared. Now again, remember we're talking surface area, so everything is squared, okay? And now that we've got that, let's go and calculate our volume. I have to erase this so that I can have some workspace. Alright, well, we decided that the area of our base here, which is what we need for volume, is 1/2 the base, which is 10, times the height, again, 5 radical 3. So same formula. Base of our triangle is 10, height is 5 radical 3. And then we're multiplying that by the height, or the altitude, so by 12, and that's how much distance is between your bases. So that will tell us how much space is completely inside. So we have 5 times 5 square roots of 3, 1/2 of 10 is 5. So 25 square roots of 3 times 12, and that should give us 522 units, and now we're talking cubic units because we have 3-dimensional space.